NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
It was November 14th, 2023. Out in the far reaches of space, well beyond the edge of our solar system, Voyager 1 suddenly went silent. No more images, no clear data, just a garbled stream of binary noise. It looked like the legendary spacecraft, after nearly half a century of exploration, had gone dark for good. Behind the silence, a critical failure in its onboard memory system, the Flight Data Subsystem, or FDS. Without it, communication with Earth was nearly impossible. Was this the end of one of humanity's most iconic missions? Not if NASA had anything to say about it. Instead of giving up, a team of brilliant scientists took a huge risk. They decided to reprogram Voyager 1 remotely, rerouting code into other parts of the probe's memory. It was like trying to perform brain surgery from 15 billion miles away. They began the process on April 18th, 2024. But here's the thing, it takes 22.5 hours just for a signal to reach Voyager 1, and the same amount of time to hear back. Every message was a leap of faith. Every test full of tension. If anything went wrong, there'd be no quick fix. Then, just 2 days later, after months of effort, calculations, and holding their breath, something incredible happened. A signal came through. Voyager 1 was alive. But what did it say? What did the probe uncover at the edge of the solar system? And why did its findings challenge everything scientists had once expected? To answer that, we have to go back to the late 1970s. That's when a once-in-175 years planetary alignment offered a rare shot, the chance to visit all 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, in a single mission. NASA acted fast. Enter the Voyager twins, Voyager 1 and Voyager 2. Though it launched second, Voyager 1 took a faster path, cruising through the void at a blazing 38,000 miles per hour, quickly overtaking its sibling. Just 13 days after liftoff, Voyager 1 snapped a now iconic photo, Earth and the Moon together, from over 7 million miles away. It was a powerful symbol, the first glimpse of our home from the great beyond. In 1979, the Voyagers reached Jupiter, and what they discovered changed science forever. Faint rings around the giant planet, 3 never-before-seen moons, and crystal-clear images of its massive satellites. One surprise, Ganymede, not Titan, was crowned the largest moon in the solar system. Another stunner, Europa, its surface glistening with cracked ice, hinted at something even bigger beneath. A hidden subsurface ocean, maybe even capable of harboring life. But that's a story for another video. Jupiter was just the beginning. As the Voyager probes approached the gas giant in 1979, scientists got their very first close-up look at the Great Red Spot, a massive storm that's been raging for centuries and is still larger than our entire planet. But this was only the first chapter in what would become one of the greatest space adventures in human history. Next up, Saturn. By using Jupiter's immense gravity as a slingshot, both Voyager 1 and 2 picked up speed and made their way to the ringed planet Voyager 1 in 1980, Voyager 2 a year later. This leg of the journey marked a huge turning point. Originally, the Voyager mission was only meant to last 4 years, with a simple goal: explore Jupiter and Saturn. But NASA had a bigger vision. They carefully plotted the spacecraft's courses in a way that left the door open for more. And when that opportunity came, they took it. But a big decision had to be made. One of Saturn's moons, Titan, stood out. It's the only moon in the entire solar system with a thick atmosphere, a potential goldmine for scientific discovery. But getting a close look at Titan came at a cost. Voyager 1 was chosen for the Titan flyby. The gravity assist needed to reach it would send the spacecraft on a new path, permanently taking it out of the planetary alignment needed to visit Uranus and Neptune. Meanwhile, Voyager 2 was cleared for the full tour. Before parting ways, both probes delivered stunning images of Saturn and its iconic rings. What scientists thought were just a few broad bands turned out to be hundreds of delicate, razor-thin ringlets, all orbiting in a precise, mesmerizing dance. The surprises didn't stop there. They found 4 brand new moons, including one that instantly grabbed attention, 1’s. Its surface is scarred by a massive crater called Herschel, making it look eerily like the Death Star from Star Wars. But it was Titan that held the biggest mystery. Instead of clear images of the surface, scientists were met with disappointment. Titan's atmosphere was completely opaque to visible light. Still, there was a breakthrough. Data showed the temperature on Titan hovered near the triple point of methane, a rare condition where methane can exist as a gas, liquid, and solid, much like water does on Earth. This opened the door to bold new theories about what might lie beneath those clouds. And just like that, the twin paths of Voyager 1 and 2 split forever. Saturn's gravity launched Voyager 1 into deep space at record-breaking speed, making it the fastest spacecraft ever launched. Voyager 2, on the other hand, kept going, setting its sights on the icy blue mystery of Uranus.
Uranus was full of surprises.
When Voyager 2 arrived, scientists quickly realized this was no Jupiter or Saturn. Those gas giants are mostly hydrogen and helium through and through. But Uranus, that was a different story. While it has a hydrogen-helium atmosphere on the outside, beneath that lies a vast, slushy ocean made of water, ammonia, methane, and even hydrogen sulfide, the same chemical that gives rotten eggs their smell. At its center, a dense core of rock and ice. This wasn't a gas giant, it was something else entirely. Later, planets like this would earn a new classification, ice giants. And if that wasn't enough, Voyager 2 made another stunning discovery. Uranus is the coldest planet in the solar system, even colder than Neptune, which orbits farther from the Sun. Once the mission at Uranus was complete, Voyager 2 set course for its final stop, Neptune. It would take 3 more years, but in August 1989, Voyager 2 became the first and still the only spacecraft to ever visit Neptune. On August 25th, it sent back the very first close-up images of this mysterious, distant world. Gene CN's Neptune appeared stunningly blue. But here's a twist. Later data revealed that it's actually closer to a deep teal. That didn't make the moment any less magical. Voyager 2 had officially completed the grand tour. But what about Voyager 1? After Saturn, it was on a one-way trip out of the solar system. Most of its instruments were shut down, leaving only the tools needed to study deep space environments. Still, Voyager 1 wasn't done making history. On Valentine's Day, 1990, from nearly 4 billion miles away, Voyager 1 turned its camera back toward home and snapped a photo that would change how we see ourselves forever. In that image, Earth appeared as a tiny, pale blue dot, just 0.12 pixels wide, barely a speck of light in the vastness of space. That haunting photo became iconic, the pale blue dot. It was the last picture Voyager 1 would ever take. Shortly after, the cameras on both spacecraft were turned off to conserve power. And then, quiet. For more than a decade, the Voyagers traveled in silence through the dark, cold edges of our solar system, until something remarkable happened. On August 25, 2012, Voyager 1's sensors picked up something unexpected, a sudden drop in charged solar particles and a sharp increase in galactic cosmic rays. That could only mean one thing. Voyager 1 had crossed into interstellar space. It had officially left the Sun's protective bubble, called the heliosphere, and entered the realm between the stars. Voyager 2 followed 6 years later, in November 2018, confirming the same cosmic threshold. The heliosphere, a vast region shaped by the solar wind, extends roughly 11 billion miles from the Sun. Its outer edge, the heliopause, marks the boundary where the Sun's influence ends and true interstellar space begins. Only 2 spacecraft have ever crossed it. Only the Voyagers, and what they've been discovering out there, beyond the edge of everything we've ever known, continues to captivate scientists, raise questions, and inspire wonder around the world. For years, scientists thought they understood how the solar wind behaved. It was believed to gradually weaken as it drifted farther from the Sun, eventually fading into the vastness of space. But then, the Voyager probes proved everyone wrong. What they found was shocking. The solar wind doesn't just fade away. It hits a wall, a hard boundary. Beyond that invisible frontier, the Sun's influence abruptly ends, and interstellar space officially begins. This barrier is called the heliopause, and it's not just an imaginary line. It's a real, physical zone where 2 cosmic forces collide. On one side, the solar wind curves and flows outward, wrapping around the heliopause like water around a rock. On the other side, interstellar plasma pushes back, flowing in from the galaxy beyond. And thanks to the Voyagers, we got something even more incredible. A sense of the heliopause's actual shape. It's not a perfect sphere. One side appears rounded like a balloon, but the other stretches far into space like a comet's tail. Even stranger, that shape isn't fixed. The outer edge of the solar system, the surface of the heliosphere, is constantly shifting. It's shaped by massive, powerful waves that ripple through space at unpredictable angles. Some of these waves are so huge they can stretch across 10 astronomical units. That's 10 times the distance from Earth to the Sun, or about 930 million miles. And here's where things get really weird. By analyzing Voyager data, scientists discovered that the heliopause can change dramatically in a surprisingly short time. That might explain why Voyager 1 crossed into interstellar space 6 years before Voyager 2, even though both were traveling similar paths. But the science doesn't fully add up. These rapid changes in the boundary defy current models and leave researchers scratching their heads. Why is it moving so unpredictably? No one knows yet, and the mysteries only deepen. Astrophysicists expected that as the solar wind slowed down near the edge of the solar system, it would heat up and grow denser, like traffic piling up before a toll booth. That did happen, but not as expected. The actual temperature and density were 10 times lower than what the models predicted. So, where did all that missing energy go? That's still an open question. What we do know is this. Interstellar space is made of cooler, denser plasma, while the area just inside the heliopause, closer to the Sun, is filled with hotter, thinner plasma. And in the middle, there's a chaotic mixing zone where particles from both sides blend together, creating a turbulent boundary layer. But the Sun's story doesn't stop at the heliopause. Voyager data also revealed something extraordinary. Shockwaves from the Sun, like the echoes of solar eruptions, can actually punch through the heliopause and ripple into interstellar space. These waves behave similarly to the ones created by supernovae, the violent explosions of dying stars, sending powerful energy surges through the galaxy. In other words, our Sun isn't just sitting quietly in its corner of space. It's reaching out, shaking the walls of our cosmic neighborhood, and the Voyagers are still out there, listening. Thanks to the incredible work of the Voyager probes, scientists made a discovery that completely reshaped our understanding of the space between stars. Turns out, the interstellar magnetic field, the one pressing in from beyond our solar system, is 2 to 3 times stronger than anyone expected, and that matters a lot. Why? Because it means interstellar particles are putting 10 times more pressure on the heliosphere, the bubble created by the Sun's solar wind, than we previously thought. That invisible tug-of-war at the edge of our solar system, it's far more intense than imagined. And this isn't just about our own star. What the Voyagers are teaching us helps scientists understand other stars too. Most likely, other star systems experience the same cosmic push and pull. These findings ripple across the entire field of astronomy, giving us a deeper, clearer picture of how stellar systems behave across the universe. But even after leaving the planets behind, the Voyagers didn't stop working. As they drift deeper into interstellar space, they continue to send home data, faint but steady signals that tell us where they are and how their aging instruments are holding up. Then, in 2022, something strange happened. Voyager 1, now 14.6 billion miles from Earth, suddenly began transmitting nonsense. The data about its orientation turned into long strings of zeros, or just the number 377 repeating over and over. Scientists were baffled. Was it trying to tell us something critical, or was something terribly wrong? Eventually, they found the culprit, a malfunction in the attitude control system, the part of the spacecraft that keeps it properly oriented in space. While NASA still had manual control, Voyager 1 had lost track of its own position, likely because of cosmic radiation damaging a key part of its navigation system. It was a risky situation, but the mission team pulled off a clever fix. They rerouted the spacecraft's data through a different onboard computer, restoring its ability to communicate. Then came an even scarier moment. On November 14, 2023, Voyager 1 fell completely silent. No signals, no data, just silence for 5 long months. It was as if the spacecraft had vanished into the void. Back on Earth, engineers raced to figure out what went wrong. Eventually, they discovered the problem. A single corrupted chip had scrambled critical flight software. And once again, the NASA team did something extraordinary. With no way to fix the damaged chip, they made the bold decision to move the spacecraft's code to a new section of memory. Bit by bit, from across billions of miles, they rebuilt Voyager 1's ability to speak to us. And it worked. Even after nearly 50 years in space, the Voyagers are still surprising us, still pushing the limits of what we know and what we're capable of. On April 18, 2024, the clock started ticking. NASA began the delicate process of transferring data to Voyager 1 in hopes of bringing it back online. But nothing about this mission is quick or simple. Just sending a single command to the spacecraft takes 22.5 hours, and waiting for a reply takes another 22.5 hours. That's nearly 2 full days just to hear back. Then, finally, on April 20th, the response came through. It worked. For the first time in 5 long months, Voyager 1 was speaking to us again. The team confirmed the signal, checked the systems, and celebrated a remarkable comeback. But beneath the victory, one reality lingered. The Voyagers are reaching the final stretch of their journey. NASA's hoping to keep the instruments running until sometime in 2025. After that, a slow shutdown will begin, system by system, as power levels drop and the spacecraft grow quiet, likely right around the 50th anniversary of their launch. Even after we lose contact, the Voyagers won't stop. They'll keep flying, silently drifting through the stars. They may pass by incredible cosmic wonders, but they'll no longer be able to tell us what they see. Voyager 1 is currently traveling at about 3.5 astronomical units per year. That's 3.5 times the distance from Earth to the Sun, or roughly 325 million miles each year. It's headed toward the constellation Ophiuchus. Fast forward to the year 4272, over 38,000 years from now, Voyager 1 will pass within 1.7 light-years of a dim little star in the constellation Ursa Minor, known as AC plus 79 3888. Voyager 2, its twin, is moving just a bit slower, about 3.1 AU per year. In 40,000 years, it'll pass near a faint red star called Ross 248, nestled in the constellation Andromeda. Right now, Voyager 1 is more than 15.5 billion miles from Earth. Voyager 2 is a bit closer, around 12 billion miles away. They've both long since crossed the heliopause, the outer edge of the Sun's influence. But here's the catch. Even though they've entered interstellar space, scientists are hesitant to say they've completely left the solar system. That's because the solar system isn't just defined by the planets or the Sun's gravity. It stretches out much farther, possibly to the Oort cloud, which could take thousands more years to reach. Scientists now believe the solar system isn't just made up of the planets, moons, and asteroids we know so well. It actually stretches out as far as the Sun's gravitational pull can reach. And that final frontier might just be the Oort cloud. The Oort cloud is a massive, mysterious shell of icy debris that surrounds our solar system like a cosmic snow globe. We've never seen it directly, it's still theoretical, but astronomers believe it's the birthplace of many of the long-period comets that occasionally swing through our skies. It's divided into two parts. The outer Oort cloud, which is more like a vast sphere, and an inner, flatter disk that's a bit closer in. Just how far out is it? We're talking 50,000 to 100,000 astronomical units from the Sun. That's about the same distance that light travels in a year. Voyager 1, the most distant human-made object, is headed that way. But even at its incredible speed, it'll take roughly 300 years just to reach the inner edge, and possibly 30,000 years to fully pass through it. And here's where the imagination kicks in. What if Voyager 1 or 2 is discovered out there, drifting silently in the darkness by another civilization? If that ever happens, they'll find a message from Earth on a gold-plated copper record mounted to the side of each spacecraft. These golden records were curated by a team of scientists led by Carl Sagan. About 3/4 of it is music, but that's just the beginning. The record also contains greetings in dozens of languages, natural sounds from Earth, like thunder, birdsong, and ocean waves, whale calls, brainwave recordings, messages from then US President Jimmy Carter and the UN Secretary General.
It's a time capsule of who we are.
Just in case someone, somewhere, ever finds it. But even if the Voyagers are never intercepted, they'll go on, quietly, peacefully, floating through the interstellar void as messengers of human curiosity and hope. They are a tribute to what it means to explore, to wonder, and to reach out beyond our little pale blue dot. Let's rewind a bit. Both Voyagers launched in 1977, just weeks apart from Cape Canaveral, Florida. Interestingly, Voyager 2 launched first, but due to a different flight path, it arrived at the edge of the solar system 6 years after Voyager 1. And along the way, they discovered something that shocked scientists. As you move farther from the Sun, you'd expect space to get even emptier. But the data told a different story. The farther you go, the denser space becomes. Interstellar space isn't a perfect vacuum. It's incredibly thin, but there are still particles out there. Inside our solar system, the solar wind, a stream of charged particles from the Sun, has an average density of 3 to 10 particles per cubic centimeter. But the farther out you go, the thinner it gets, until you hit a sudden wall. That invisible wall is called the heliopause, the boundary where the solar wind slows down and stops. It's the edge of the Sun's bubble of influence, known as the heliosphere. Everything inside the heliosphere, from Mercury to Neptune and beyond, rides inside this massive protective bubble. At the heliopause, the solar wind drops to 0, and the density of particles dips to an astonishingly low 0.002 per cubic centimeter. Beyond that, it's interstellar space, a realm that's strange, cold, and still holding secrets, ones the Voyagers are still helping us uncover, even as they drift farther from home than anything we've ever sent.
Based on previous calculations,
Scientists expected that once you cross the heliopause, the outer edge of the Sun's influence, the particle density in interstellar space would be about 0.037 particles per cubic centimeter. And at first, the data lined up. When Voyager 2 reached 119.7 astronomical units from the Sun, that's about 11 billion miles, or 17.9 billion kilometers. Its instruments recorded a density of 0.039 particles per cubic centimeter. Practically a perfect match, but then something unexpected happened. Just a few billion miles farther out, at 124.2 AU, roughly 18.5 billion kilometers from the Sun, that number jumped to 0.12 particles per cubic centimeter. That's more than triple what we expected. Why is space getting denser the farther we go from the Sun? That's a mystery we'll dig into soon, but before we get there, let's zoom out. Because it turns out, the heliosphere isn't the only cosmic bubble we're floating in. There's a much bigger bubble out there, one that changes how we think about our place in the galaxy. When you look at images of deep space, it might seem like the universe is packed with glowing clouds of dust and gas. But astronomers began to notice something strange back in the 1970s and 80s. The area of space around our Sun looked oddly empty, almost like we were suspended in a vacuum. Fast forward to today, researchers at the Harvard-Smithsonian Center for Astrophysics, CFA, recently confirmed it. We really are inside a cosmic void. Using advanced computer simulations and a 3D reconstruction of the local galaxy, they discovered that the Sun and Earth sit almost dead center in a massive balloon-like structure stretching 1,000 light-years wide. They've named it the local bubble. So how did this enormous structure form? Roughly 14 million years ago, a series of about 15 massive stars exploded in supernovae over the course of a few million years. The sheer force of those blasts pushed the surrounding interstellar gas outward, like a shockwave, carving out a vast, low-density cavity in space. That's the bubble we now live in. What's more, it's still expanding, and fast. When the local bubble first formed, it grew at an astonishing speed of 60 miles per second, based on data from the European Space Agency's Gaia Observatory. So, here we are, tucked inside two invisible but very real cosmic bubbles, the heliosphere created by our Sun and the far bigger local bubble formed by ancient stellar explosions. And just like that, the universe reminds us how small, but incredibly special, our place in it really is. Right now, our cosmic neighborhood, the local bubble, is still growing. It's expanding at about 4 miles per second. And along the surface of this vast bubble, scientists have found 7 stellar nurseries, dense molecular clouds, where new stars are being born. But here's where it gets even cooler. Star formation isn't unique to our bubble. It's happening all around the galaxy, on the edges of other bubbles just like ours. So it's entirely possible that other stars and even planets like Earth are sitting inside their own protective bubbles, scattered across the Milky Way. And get this, the Sun wasn't always chilling in the center of our bubble. When the chain of supernova explosions first created the local bubble, the Sun was way off in another part of the galaxy, around 1,000 light-years away. But over millions of years, as our solar system orbited the galactic center, it drifted right into the middle of the bubble. That shift wasn't just theoretical. As astrophysicist João Alves from the University of Vienna points out, it's backed by physical evidence. Scientists have discovered traces of radioactive iron isotopes from ancient supernovae in Earth's crust. It's like a cosmic breadcrumb trail, pointing to our solar system's close brush with those explosions. Now here's where it gets truly mind-blowing. Astrophysicist Alyssa Goodman of the Harvard-Smithsonian Center for Astrophysics, who helped found the GLUE project, short for Galactic Legacy Infrared Mid-Plane Survey Extraordinaire, says the fact that the Sun is sitting near the middle of one of these giant bubbles can't be a fluke. Statistically, it only makes sense if these bubbles are everywhere. And that's the current thinking. The Milky Way is full of them. These star-forming bubbles are the result of supernova blasts, each explosion carving out another hollow in space. The result? A galaxy that looks a lot like Swiss cheese, where each hole was punched out by a dying star and new stars are being born along the edges. According to the researchers, the Sun has probably traveled through multiple superbubbles over its lifetime, each one shaping the conditions for star formation, planetary evolution, and maybe even life itself. What's next? The team plans to map even more of these cosmic bubbles to create a full 3D map of their shapes, locations, and sizes. By doing so, they hope to unlock answers about how these structures interact, how they influence the birth of stars, and how galaxies like ours change over time. With this new understanding, our solar system starts to look a lot less isolated and a lot more connected to the bigger picture of the universe. At the heart of it all sits our familiar Sun, surrounded by its 8 orbiting planets. But now, we know it's also cradled inside a layered cosmic structure, shaped by ancient explosion. The last stop on our solar system tour is Neptune, sitting way out there, about 4.45 billion kilometers from the Sun, or roughly 30 times farther than Earth. That's 30 astronomical units, AU to be exact. But beyond Neptune, the solar system doesn't just fade into darkness, it keeps going. Next up is the Kuiper Belt, a distant region packed with icy leftovers from the solar system's early days. You've probably heard of its most famous resident, Pluto, once considered the 9th planet. The Kuiper Belt stretches out to around 55 AU from the Sun. Now things start to get interesting. Past the Kuiper Belt, between 125 and 135 AU, lies the heliopause, the invisible bubble that marks the boundary between our Sun's solar wind and the vast expanse of interstellar space. We've talked about it before, but here's where the real action happens. At the edge of this boundary, something wild takes place. Solar plasma, charged particles constantly blowing out from the Sun, smashes head-on with interstellar plasma coming from the rest of the galaxy. Imagine 2 speeding rivers colliding. It's no surprise that right at the crash zone, the density skyrockets, just like a cosmic traffic jam. And beyond that jam, stretching 3/4 of a light year to about 1.5 light years, is the Oort cloud, a giant spherical shell made up of icy objects, possibly 1 trillion of them, and the birthplace of long-period comets that sometimes dive toward the Sun after millions of years in deep freeze. Now, here's the big question. So what? Why does any of this matter to us, floating on our little blue planet inside these enormous cosmic bubbles? Let's start with the heliosphere, the smaller of the 2 bubbles. It's our shield. That high-density traffic jam at its boundary acts like a barrier, helping to block dangerous high-energy particles that zip through space from the center of our galaxy. Without it, Earth would be constantly bombarded by radiation intense enough to wipe out life as we know it. Now, zoom out to the local bubble, our neighborhood in the galaxy. It may be enormous, but it still plays a role in our cosmic safety net. To understand why, picture the Milky Way, a massive spinning spiral galaxy with arms stretching out like a pinwheel. Right now, our Sun is cruising between 2 of those spiral arms, the Sagittarius arm and the Perseus arm, sort of like driving on the highway between 2 big cities. And yes, our Sun is on a road trip around the galaxy. One complete orbit takes about 200 million years. We call that a galactic year. And since humans showed up, we've only lived through about 0.0008 of a galactic year. Barely a blink. But here's the twist. On this journey, the Sun doesn't just glide smoothly through empty space. It's passed through dense clouds of interstellar gas, where particle density can spike hundreds of times higher than usual. Some of these encounters could have dramatic effects on the solar system, and possibly even life on Earth. So yes, we're in a bubble. Actually, two bubbles, one from the sun, one from ancient supernovae. And together, they don't just surround us, they protect us, influence our environment, and tell a story about where we've been in the galaxy and where we're going next. Astrophysicist Miroslav Filipovich took a deep dive using the latest models of the Milky Way to figure out what Earth went through when the sun passed through the galaxy's spiral arms, regions where the space around us is packed with way more interstellar material. What he found was pretty striking. The sun's journey through these dense arms lines up closely with 5 major mass extinction events on Earth, happening around 415, 322, 300, 145, and 33 million years ago. So here's the big takeaway. Right now, our sun is cruising through what you could call a cosmic safe harbor, a quiet neighborhood that's just perfect for life as we know it. And honestly, humanity is incredibly lucky. We showed up on Earth just as the sun settled into this local bubble, a vast, nearly empty bubble in space that shields us from the chaos outside. Could our existence be linked to this cosmic refuge? Maybe. Science hasn't cracked that mystery yet, but one thing's clear. The stunning, star-filled sky we see above isn't just luck. It's because we live in this huge void, this local bubble. If space around us was denser, filled with clouds of gas and dust, many of those stars would be hidden from view. And who knows if we'd even understand the universe as well as we do now if we were stuck in that cosmic darkness. In a way, the local bubble feels like a gift to humanity, just in time for us to step into the space age and start dreaming bigger than ever before. Now, if we think about future interstellar travel, there's a major hurdle: dust. At the mind-boggling speeds spaceships would need to reach other stars, even tiny dust particles could slam into them with devastating force, slowly grinding a ship to dust. But here's the cool part. Space seems to have already cleared a path for us. The local bubble has swept away much of the dust near the sun, almost like it's saying, "Go ahead, explorers, your way to Alpha Centauri, Tau Ceti, and beyond is open." At first glance, space might seem like a vast, empty wasteland, totally silent and lifeless, with no sign of any other civilization out there like us. But does that really mean the universe is quiet and alone? Are we the only ones who've tried to reach beyond our little corner of the cosmos? Recent discoveries suggest the answer might be a lot more interesting. Take Voyager 1, for example. The farthest human-made object from Earth, it's been drifting through space for almost 44 years, still sending data back to us. And then, out of the blue, scientists picked up something totally unexpected, a strange cosmic hum. Sure, Voyager has sent back signals before, but this new one was different, almost eerie. It came from a staggering distance, over 14 billion miles away from Earth. This hum held steady at about 3,000 cycles per second, or 3 kilohertz, for nearly 3 years straight. That makes it the longest-lasting, most consistent cosmic hum Voyager 1 has ever recorded. But where does it come from? Most scientists think it's the sound of plasma waves, those invisible, charged particles that make up most of the stuff in space, traveling somewhere deep out in the universe. What really blows your mind is that the hum didn't fade even as Voyager zoomed another billion miles further out. That kind of steady signal has some researchers wondering if there's an unknown energy source out there, quietly powering this cosmic hum. But here's the catch: space is a vacuum, which means sound as we know it shouldn't travel through it. Without enough particles to carry the vibrations, sounds from huge events like black hole collisions or supernova explosions simply can't make it to us. To get a sense of this, try this simple experiment. Put a tiny bell inside a sealed plastic bottle and shake it. You'll hear the bell ring loud and clear. Now, light a couple of matches inside the bottle and seal it quickly so they burn out. When the air cools down, shake the bottle again. Notice anything? The sound is way quieter, sometimes almost gone. That's because the air inside is thinner, making it harder for the sound to travel. In the emptiness of space, it's like that, but even more extreme. Yet somehow, Voyager caught this mysterious hum, and it's a clue that the universe might be whispering secrets we're only just beginning to hear. Even though space is mostly silent to us, there's a whole world of electromagnetic waves zipping through the vacuum, and radio waves are one of the stars of the show. Our ears can't pick them up, but scientists have figured out how to translate these signals into sounds we can hear, and that's how we're able to listen in on the messages Voyager 1 is sending back from the edge of the solar system. But how does Voyager manage to catch these incredibly faint signals and beam them all the way back to Earth? The spacecraft is packed with two super-sensitive antennas built to detect tiny changes in plasma, the charged particles floating through space, and record them. But even though radio waves travel at the speed of light, the sheer distance means a message takes over 20 hours to make the trip. That's a long wait for any reply. Here's the bittersweet part. Voyager 1 is slowly running out of power. Scientists estimate that its vital instruments will only last 3 or 4 more years. It's already far exceeded our wildest expectations, but it still might surprise us with a few more groundbreaking discoveries before the lights go out. Voyager's latest find is pretty amazing, but it's not the only strange space sound that's baffled scientists. Back in 2007, researchers digging through old data stumbled across something really weird: fast radio bursts, or FRBs. These are ultra-brief blasts of radio waves that last just a millisecond. Since then, astronomers have been hunting for more, and they've found tons of these mysterious bursts. They sound like this. Imagine a sample sound here. The more we discover about the universe, the more it seems to ask new questions. Could these be messages from an intelligent alien civilization trying to reach out? Or maybe they're signals never meant for us to hear in the first place. Most astrophysicists think FRBs come from extreme cosmic events, maybe black holes or neutron stars, which are tiny but insanely dense remnants of dead stars. But here's the kicker. Some scientists have a wilder theory. They suggest these bursts might actually be powerful, misdirected alien radio beams meant to power massive, light-driven spacecraft far across the cosmos. Whatever the truth, everyone agrees on one thing. These FRBs come from unimaginably distant places, billions of light years away, way beyond our own galaxy. And while our technology can't fully explore those far-off realms yet, NASA keeps catching mysterious, spooky signals much closer to home, right inside our own solar system. Let's zoom in on one of Jupiter's most fascinating moons, Ganymede. Now, get ready for this. Here's the eerie sound it makes. What you're hearing comes from something called chorus waves, which are coherent electromagnetic waves. These waves are often behind those stunning light shows we call auroras, you know, the northern and southern lights. And guess what? Earth isn't the only place that gets to see these amazing light displays. Auroras also light up the skies on Saturn, Jupiter, and Ganymede. So basically, that haunting sound you just heard, it's like the converted voice of Ganymede's own polar lights. Pretty wild, right? But what about Mars? We've been studying the red planet for a while now, and NASA's Perseverance rover just stumbled onto something really cool. For the first time ever, we've got an actual recording of Perseverance rolling over Mars' rocky surface, and along with the clatter of metal wheels, the rover picked up a strange, high-pitched scratching noise. Here's the real recording from Perseverance. No one knows what's causing that mysterious scratch yet. NASA scientists are digging for answers, but the mystery is still wide open, leaving plenty of room for imagination. Meanwhile, science and tech keep pushing forward. Fast forward to 2030, and there's talk of a brand new interstellar probe mission that could shake things up just like the first moon landing did back in the day. Picture this: the biggest rocket ever built, rocketing out at top speed, aiming to travel at least 10 times farther than Voyager 1 has gone. This spacecraft could have a lifespan of 50 years or more, and given what Voyager has achieved with older tech, everyone's hoping we can beat that. This mission would mark humanity's first real step beyond our solar system, capturing epic images of our cosmic neighborhood from way out there and then pushing deeper into interstellar space. Once that happens, we'll finally be closer than ever to understanding our place in the universe and unlocking the secrets of the vast unknown.
Believe it or not,
Only 5 spacecraft ever launched by humans have had enough speed to break free from our solar system. 2 of the most famous are the Voyager probes, Voyager 1 and Voyager 2. These legendary explorers have gone way beyond what anyone expected, uncovering jaw-dropping discoveries and lasting far longer than NASA ever predicted. Honestly, they don't get nearly enough credit for what they've done. So let's dive into some cool facts about these incredible machines, what they've found, what they're still up to, and where they're headed next. The Voyager mission officially kicked off in 1972, but it actually started out with a different name, Mariner, Jupiter, Saturn. The probes themselves were initially called Mariner 11 and Mariner 12, but NASA decided to rename them Voyager because these spacecraft were leaps and bounds ahead of the earlier Mariner series, basically next-level tech for their time. Speaking of tech, let's take a quick trip back to 1977, when Voyager 2 blasted off on August 20th and Voyager 1 followed just 2 weeks later on September 5th. This was a period when scientists were making huge strides in something called gravity-assisted orbital trajectories. In simple terms, that's the genius trick of using a planet's gravity like a cosmic slingshot, catapulting a spacecraft to much higher speeds, as long as it follows a precise flight path. Now let's talk computers. Both Voyagers are equipped with identical systems, and get this, they're built with dual redundancy. That means every critical piece has a backup just in case something goes wrong. But here's the kicker. Each Voyager computer has a whopping 69.63 kilobytes of memory. Yeah, that's enough to hold just one average JPEG photo, not exactly what you'd call cutting edge by today's standards. And all their scientific data, it's stored on vintage digital 8-track tape machines. These humble-looking machines have traveled billions of miles, sending back some of the most valuable data in space exploration history. It's wild to think how much we've learned from probes with tech that would seem ancient to us now, yet they keep pushing onward, farther than anything else we've sent out there. Now, don't get the idea that these tape recorders on Voyager are like your grandpa's old 8-track player sitting in a vintage muscle car. Nope, there aren't any physical examples of these floating around in museums or garages, but lucky for us, we do have a photo of the actual data tape recorder used on both Voyager spacecraft. This beast was subcontracted to Lockheed and built by Odetic's core team specifically for Voyager. It could record data at 2 different speeds, a blazing 115.2 kilobytes per second and a slower 7.2 kilobytes per second. When it played back the data, it did so even more slowly, topping out at 57.6 kilobytes per second, with options for 33.6, 21.6, or even 7.2 kilobytes per second. What exactly the magnetic tape was made from, and the secret source that kept it from breaking down in the brutal conditions of space, remains a bit of a mystery. But whatever those secrets were, they worked like a charm. Both tape recorders performed perfectly from launch through the entire Grand Tour mission, and even during the extended journey that sent these probes beyond our solar system. Here's a mind-blower for you. Voyager's computers can handle about 81,000 instructions per second. Sounds like a lot? Well, your smartphone, probably the one you're watching this on, is about 7,500 times faster. When it comes to sending data back to Earth, the Voyagers are working at just 106 bits per second. To put that into perspective, if you tried to download a 5 gigabyte Netflix movie at that speed, it would take you roughly 8.5 years. Yeah, patience is definitely a virtue in space. But here's what really sets the Voyagers apart. Each one carries a golden phonograph record. These aren't your typical vinyl records, they're gold-plated copper discs packed with treasures from Earth, 115 analog-encoded photos, greetings in 55 languages, a 12-minute sound montage from our planet, and 90 minutes of music. All of this was included just in case an alien civilization ever stumbles upon these spacecraft. Kind of like a cosmic message in a bottle. Powering each Voyager are 3 plutonium dioxide radioisotope thermoelectric generators, or RTGs, tucked away on the end of a long boom, and each probe is loaded with 11 different scientific instruments. Explaining them all in detail would take hours, but let's just say they captured some incredible data and mind-blowing images along the way. Both Voyagers are blazing their own paths through space, cruising at different speeds and trajectories. Voyager 1 is the speed demon, flying at around 61,155 kilometers per hour. Voyager 2 follows behind at a solid. Voyager 1 gave us some mind-blowing images of Venus, Jupiter, Neptune, Saturn, and Uranus, the giant planets of our solar system. One of its most jaw-dropping moments came when it snapped a photo of Jupiter's moon Io, catching a volcano erupting in real time. That was the first time anyone had seen an active volcano anywhere other than Earth. But the shot that really stole the spotlight, the famous pale blue dot, a tiny speck of Earth captured from 6 billion kilometers away on February 14, 1990. That tiny blue dot inspired Carl Sagan's iconic book, A Pale Blue Dot, a vision of the human future in space, reminding us just how small and fragile our home really is. Meanwhile, Voyager 2 was busy too. It started sending back incredible images of Jupiter on April 24, 1979. Scientists stitched those images into a time-lapse movie showing the planet's swirling atmosphere and the legendary Great Red Spot, a storm so huge it's 3 times the size of Earth. Voyager 2 got closer to Jupiter and its moons, giving us a front-row seat to these spectacular sights. Then, on August 25, 1989, Voyager 2 zipped past Triton, one of Neptune's moons, sending back data that let scientists create an amazing video of the encounter. Thanks to both Voyagers, we explored all the gas giants, checked out 48 moons, discovered unique ring systems, and studied the magnetic fields of these outer planets like never before. But the Voyagers didn't stop there. They ended up uncovering something way more mysterious, stuff they weren't even built to explore. Voyager 1 made history on August 25, 2012 by becoming the first human-made object to leave our solar system and enter interstellar space. As it crossed the edge of the heliosphere, the sun's massive bubble of charged particles, Voyager 1 recorded a dramatic 1,000-fold drop in those solar particles and a 9% jump in cosmic rays coming from beyond our solar system. Since then, Voyager 1 has been sending back clues about what this dark, unknown region is like. It turns out cosmic radiation out there is intense, showing us how particles from the sun clash with those from other stars. This massive bubble of charged particles, the heliosphere, actually shields everything in our solar system from deadly cosmic rays. Then, on November 5, 2018, Voyager 2 followed suit and became the second spacecraft to break into interstellar space. It detected a sudden drop in solar wind particles and, just like Voyager 1, saw an increase in galactic cosmic rays and a stronger interstellar magnetic field. Fast forward about 40,000 years, and Voyager 2 will cruise within just 1.7 light-years of a star called Ross 248, hanging out in the constellation Andromeda. But here's the bittersweet part. Way before then, we'll lose contact with both Voyagers forever. They'll drift off quietly into the vast empty stretch of interstellar space, out of reach and silent. Imagine though, just maybe, millions of years from now, some alien civilization somewhere in the cosmos stumbles across one of these probes. If they figure out how to power it back up, that old rusty spacecraft could come to life one more time, sending messages from our distant past. So stick around and keep watching. Who knows what new surprises the Voyagers might still send us? Thanks for joining the journey through our incredible universe.